To prepare for the ACT, let's look at question 59. Question 59 states, the figure shows a flying kite. At a certain moment, the kite string forms an angle of elevation of 75 degrees from point A on the ground. At the same moment, the angle of elevation of the kite at point B, 320 feet from A on the ground, is 60 degrees. What is the length in feet of the string? To answer this question, we need to use the law of sines. In order to use the law of sines, we need to find the angle across from our given side length, or our ground, so we are finding this upper angle here, and I'm just going to call that x. To find this angle, we know that triangle sum is 180 degrees, and we can use that to create an equation. So we have 180 is equal to x plus 75 plus 60. We can use our NumWorks graphing calculator to quickly compute for x of our missing angle. So in our calculation app, we have 180 minus 75 minus 60, and that will give us our angle, or x, to be 45. Now we can use our law of sines to find the length of our string, which I will call y. The law of sines states that we can take an opposite side, so 320, and divide by the sine of the angle opposite of it. So we have the sine of 45 degrees. And that is equal to another side, or I'm going to use the string, which is y, divided by the sine of that angle opposite of it, and in this case, we have 60. Back in our NumWorks graphing calculator, we can now solve this equation using our equations application. Going back to our home screen, we're going to go into our solver. We also want to verify that we are in degree mode, which we are. We can now create an equation using an empty template. I have 320 divided by the sine of 45 is equal to, so shift pi, my variable, you can use x or y, I'm just going to use x in this case to make it easier, divided by the sine of 60. I go down to solve the equation, and I can get that x, or in this case, y, is equal to 160 square root 6. Which is answer choice B. For more ACT practice, visit numworks.com.